Okay, this is lesson 29 and we are going to solve these 10 problems. They are about the area of a region bounded by curves, different curves. We do the practice and let's go with the first problem. Now, one advice I advise you when you see the video, when you see the explanation, put the speed of the recording at 1.5 or maybe 1.75 because I'm talking too slow today. I'm feeling a little bit tired and maybe this is the reason why I'm talking too slow. But try to put the speed higher. Maybe 1.5 will be where you measure how you want to do it. Okay, let's go to do all the problems. The first problem say find the area of the region bounded by the curves y equal x squared minus 1, y equal minus x plus 2, x equals 0 and x equals 1. The line x equals 0, where is the line x equals 0? The line x equals 0 is exactly the y-axis. The line x equals 1 is a vertical line that passes through the line x equals 1. The line x equals 2 is the line that is a vertical line passing through x equals 2. So it's the set of all the value where x equals 2. This is the line x equals 2. The line y equals 1, for example, is the line of is the horizontal line where all the points are equal 1. So it's this line, y equals 1. Y equal minus 1 is this line, or minus 3. Y equal minus 3 is the line that all the points on the line, y equal minus 3, all the points have as a component for the y minus 3. Maybe this point is minus 1, minus 3. But the line y equal minus 3 is the horizontal line whose points have y equal minus 3. Okay. So we have to do the regions are bounded by the two curves. The first curves is by four curves. There are four curves. The first curve is the parabola. This is the parabola when x equals 0, y equals minus 1. So this is the point minus 1. So the parabola does like this when x equals 1, y equals 0. When x equals 1, 1 squared minus 1 is 0. So this is the point of intersection with the x-axis, and same from x equals minus 1. So the parabola does like this. This is a rectilinear line with a slope minus 1, and when x equals 0, y equals 2. So it starts here and goes down with a slope minus 1. And when y equals 0, x equals 2. So it intersects this with the x-axis at this point. So this is the four lines are the line x equals 0, the line x equals 1. Let's go to draw the line x equals 1. X equals 1. And the two graph. Let's go to put it another color for the graph. So this is one graph. Maybe this color for the parabola. Okay, this is the parabola. And let's go to leave and maybe yellow for the rectilinear line. Okay, and the area bounded between x equals 0, x equals 1, and the other two curves is this area. From x equals 0 to x equals 1 is this area, and this is the area that you will not be able to calculate using, you see here I see a triangle here. It's a triangle, it's a rectangle, but you will, oh no, it will be the area, sorry, from x equals 0 to x equals 1, well, will be only the area of the rectangle and the triangle. So I can, no, and this area, also. Okay, this is the area that you will not be able to find without using calculus. This one, because it has a shape that is not a rectangle. So the area of this is the area of three parts. This part is a triangle, the base is 1, the height is 1. This area is a rectangle, is 1 by 1, but this area is the area bounded by a parabola, by a part of the parabola, bounded by x equals 0, and bounded by the point x equals 1. Well, this area is more difficult. Let's go to apply what we said. So please erase this area. Erase this area. This area is not going to anywhere. Sorry. We said this. You need to draw the regions because you need to know which are the upper function. And the upper function is this one, the rectilinear line. What is the lower function? The lower function is the parabola. So when you do the integral, when you find the area will be the integral from x equals 0 to x equals 1 of this distance. Let's go to place this distance. Of this distance. This is the area that I'm going to consider. So it's the sum, so let's go to right here for the first problem. The area is the sum of all the pieces like this one. And this piece have the length f of x, if I call this one, the upper one, the f of x, minus g of x, and this will be this distance. F of x minus g of x will be all this distance, because g of x is negative, so f of x minus something negative will be positive by the width delta x. So the area will be the sum of all pieces like this one, and the sum of all pieces like this one is the integral of f of x minus g of x ddx. From x equals 1 to from x equals 0 to x equals 1. So we need, the problem is almost solved. We need to now plug in who is the upper function minus the lower function. We need now to plug in the upper function, to plug in the lower functions, and to make the integral. Let's go to do it. Also, pay attention that, for example, when you do f of x, when you do here f of x minus g of x, let's say that you are going to cover from 0 to 1. But let's say that the problem say to cover a more wide regions. You see here, you see this area. This area is how you cover the region bounded by the curves. And the length is the upper minus the lower. And the width of the area of this is the upper minus the lower, is the area of our rectangle, is by delta x. And so what you are doing exactly is making the sum of all the pieces that are inside the regions, and collecting the sum give you the area, the total area that are bounded by the curves. Okay, now let's go to do the problem. The function f of x, the upper function, is the function minus 1x, slope minus 1, plus 2. And the function g of x is the function x squared minus 1. And I need to do the integral from x equals 0 to x equal 1 of f of x minus g of x minus x plus 2 minus x squared minus 1 d dx. So this is the integral from x equals 0 to x equal 1 of minus x squared minus x squared minus x plus 3 d dx. This integral, easy to do it. The antiderivative of this is minus x cubed divided by 3 minus x squared divided by 2 plus 3x. And the fundamental theorem of calculus say if you want to find the area, find the antiderivative, already found. Evaluate between x equals 0 and x equals 1, and you will find the area under this curve. But the area under this curve represents these small areas, the sum of all the pieces of areas like this one. The evaluation is easy because x equals 0 is a good limit of integration. Well, it will give you minus 1/3 minus 1/2 plus 3 by 1 minus 0. And this will be equal whatever, whatever you make the sum. And this is the area. Okay, problem number 2 is find the area bounded by the four curves y equal minus x cubed plus 3, y equal x equal minus 1, and x equal 1. Okay, the strategy is to draw these functions. The function x equal 1 is easy. Is the horizontal line at x equal 1, is the vertical line at x equal 1. So it will be something, well, you know, x equal 1, so it will be the horizontal line x equal 1. This is the line. X equal minus 1, it will be, if this is minus 1, will be the vertical line where is the set of all the points when x equal minus 1. All the points in these rectilinear lines, all the points have x equal minus 1. Okay, so it's between these two regions, x equal 1 and x equal minus 1. Now we need to draw the function minus x cubed plus 3 and the function y equal x. Well, the function y equal x is easy, is a rectilinear line with a slope 1 that pass through the point 0, so it's this rectilinear line. Okay, this is the function y equal x, slope is 1, or the tangent is tangent of the angle is 1, or the angle here is 45 degrees. The angle here is 45 degrees, and this is y equal x. This is the line, y equal x. Now let's go to learn how to graph y equal minus x cubed plus 3. The graph of y equal x cubed does something like this. It's something similar like a parabola on the positive side of the axis. This is the y-axis. This is the x-axis. Okay. This is the x-axis, the y-axis. So it does like this. It does positive. It takes the point x, imagine 2, and make the height 2 to the cube. So this height will be 8. So if you take the 2, the point will be 2,8. Now, in the negative side, it takes the point minus 2 and convert it into a negative number. So it will be minus 8. So the graph of y equal x cubed, it will be something like this. It will be something like this, okay? Something like this. And this is the graph y equal x cubed. And of course, that, let me draw better. Of course, when x big, the function is very big. So the problem is asking me to find the area between x equal minus 1 and x equal 1, but not of the function x cubed. So now, what is the function minus y equal minus x cubed? Is the function that is this function y equal minus x cubed. This function is the function y minus x cubed because it assigns, instead of going up at this x, is minus x cubed, going downwards. This number, minus 8, is going up. So this is the function minus x cubed. So what is the function minus x cubed plus 3? Is the same function, this one, but 3 units up. So it will be 1, 2, and 3. So it will be the function like this. Okay. And now we have to find the area. So maybe we do a clean draw and we do the problem. Now what I have done, I have used GeoGebra. GeoGebra allows you to put the function, to write the function, and they make the graph of the function. So the graph of minus x cubed plus 3 does like this, and you see here the slope is 0. In my graph, you don't see the slope 0. It's bad draw. The slope is 0, so this is the graph of minus x cubed plus 3. This is the graph of y equal x. And the graph of x equal minus 1 is the vertical line, x equal minus 1. And the graph x equal 1 is this vertical line. So why we are doing this? We are doing this because we want to make sure that on the interval x equal minus 1, x equal 1, on this interval, the area, the function, the upper function is always the upper function. So we are doing this area. we are taking these pieces like this, and we are summing all the pieces. So to make sure that all the pieces are with the upper function, is the upper function always from x equal 1, yes, to x equal minus 1, so is this area that I'm finding, all this area, and the upper function is always the upper function, and the lower function is always the lower function. So no problem in this problem. No problem. So let's go to do the problem. So the area, the sum of all these small pieces will be the integral of, let me put this bigger, so it will be the integral of the upper function. It will be the integral from x equal minus 1 to x equal 1 of the upper function minus x cubed plus 3 minus the lower function minus x ddx. And this sum will sum all the pieces, and the sum of all the areas, of all these small areas, of all the rectangle will be, when you cover all the small rectangle, will give you the total area that is bounded by the four curves. By these curves, here by this curve, x equal minus 1, by this curve. So the problem now is to make the integral. I think that this is easy to do it, right? It will be minus x4 divided by 4 plus 3x minus x squared divided by 2, and everything you evaluate between minus 1 and 1, and the problem is done. Well, let's go to do it. Minus x4 divided by 4 plus 3x minus x squared divided by 2, evaluate between x equal minus 1 and x equal 1. So I don't want to do this evaluation. I want you to do it because you will practice. Okay, you do it. Okay, we now do this problem to practice. Find the area of the region bounded by the curve y equal the cubic root of x minus 1 and y equal x minus 1. It doesn't say you need four curves. It doesn't say between x equal 1 and x equal 2. It doesn't say, but for sure these two curves have an intersection, and the intersection will tell you what is the area. Okay, let's go to do it. So the first thing is, what is the graph of the cubic root of? So the graph will do something like this, with infinity slope of x equals 0, and through here, when x is negative, the cubic root of a number is a negative number. For example, the cubic root of minus 8 is minus 2, because minus 2 multiplied by minus 2 multiplied by minus 2 is minus 8. Okay, so this is, but the graph is not the cubic root of x. Is the cubic root of x minus 1. How we will represent this graph? This graph is the same graph, but is translated one unit to the right. So is this graph. With a slope infinity and x equal 1, I will do like this. And the graph of y equal x minus 1 is the graph of a rectilinear line with a slope 1 that when y equals 0, x equals 1. So it will be this line. It will be this line, the line that passes through the point x equals 1. It passes when y equals 0, when in this equation, when y equals 0, x minus 1 equals 0, so x equals 1. So it's the graph with a slope 1, and this is the graph y equals x minus 1. And it say, let me continue this graph. Let me continue this line like this. It say find the area bounded by the two curves. Wow, what is the area? It refers to this area, these two pieces. So this area is a positive area. This one is also a positive area because we make sure to produce the area like the sum of pieces like this one. Like this one. Like this one. The sum of pieces like this one. These pieces where this length, the length is positive by delta x, positive. So it's the sum of all these pieces. Now we have something here different from the other problem. First of all, we need to find this point because you see that there are missing information here, and the missing information is from where we have to find the area, from this point, from x equal this point to x equal this point. We need to find this point of intersection. And the second thing, the second detail that this problem is asking you is pay attention to the following one thing. The upper function on this region, from x equal, we will find this x now, to x equal 1, the upper function is y equal x. But the upper function on the interval x equal 1 to this point is y equal square cubic root of x minus 1. So we need to make the difference between the upper minus the lower. So we need to do two intervals, from this point to this point, and from this point to this point. So let's go to do it. So the first thing is to find the point of intersection, these 2 points, this point. This one is the point x equal 1. But who are these points? These points are being obtained by imposing the condition that the y have the same y is for y equal x, and from y equal cubic root of x minus 1. The same y occur here, and the same y occur here. So I will say the first function is y equal x minus 1. The second function is, let's say, y1. y2 equal the cubic root of x minus 1, and y1 when y1 equal y2. What is the point? Is when x minus 1 is equal to the cubic root of x minus 1. So this will allow me to find the x. So let's go to find the x. So x minus 1 to the cube is equal x minus 1. So how I will solve this equation? maybe I will put x minus 1 cube like x minus 1 multiplied by x minus 1 squared. And this should be equal to x minus 1. So these two functions will cancel. So x minus 1 squared should be equal 1. Okay, so what? So let me write here in case that I'm making a mistake. So we divide by x minus 1 the whole equation, and if we divide by x minus 1, we will have x minus 1 squared equal 1. Now we find that x squared plus 2x, x squared plus 1 minus 2x equal 1. So now the 1 will cancel, and we will end with x squared minus 2x equals 0, or x that multiply at x minus 2 equals 0, or x equals 0, or x equal 2. And now I have the two vertical lines where I have to do the integration from x equals 0 to x equal 2. But pay attention, you cannot do like this. You have to do it in two steps, because the upper function will change from x equal 1 to x equal 2. So we need to do the integral in two steps. So if you graph this function, the graph of this function will be this one. Now the two functions will be, one will be the cubic root of x minus 1, and this is the graph y equal x. This is the graph y equal x minus 1, okay? As you see, and the area that we have to find is the area from x equals 0 to x equal 2. So these two vertical lines, okay, x equals 0, and the area bounded by the two curves are this area, and this area. So let's go to find. Now you see, you pay attention when the upper curve is y equal x in this region from 0 to 1, while from 1 to 2 the upper curve is the cubic root of x minus 1. So we need to do the steps we need to do the integral in two steps. So let's go to do it. Okay, so it will be, the area will be the integral of the from x equals 0 to x equal 1. So I'm going to sum all these pieces, okay, from of the upper curve. The upper curve is the x minus the lower cubic root of x minus 1, plus the area of this region, that is the integral from x equal 1 to x equal 2 of the upper curve, the cubic root of x minus 1 minus the lower curve, y equal x, v dx. So you do the integral, and you will find an answer. I suppose that this area is the same area that here for symmetry. So maybe if you multiply by 2 the integral from 1 to 2, you will also obtain the same result. So this is just an integral, easy integral to do. Good luck. Okay. Well, as you see, in this kind of problems, the important thing is not to do the integral. The important thing is the setup of the problem. Let's go to do the next problems, and we do only the setup. But, well, I see that I made a mistake. If you see here, the x is the x is the upper function, but it's not x, it's x minus 1. This function, this rectilinear function is x minus 1. So please correct here and put x minus 1. And here is the upper between x equal 1 and x equal 2 is the upper, that is the square, the cubic root of x minus 1, minus the lower function. But the lower function, the bottom function is x minus 1. No, it's not x. Please correct to do if you want to do the integral. I'm sorry. Now let's go to do this problem faster. Imagine they give you two curves, the x equal y square. X equal y square can represent in the following way. This is the x-axis, this is the y-axis. X equal y square takes a y, let's say 2, and put it, or 1, and put it in the 1. Or let's say take the 2 and put it in the 4. Take 3 and put it in the 9. So x equal y square is this curve. And what is x equal y plus 2? X equal y plus 2, take the number 3 and put it in the 5. Okay? This is the two curves. So I can represent the two curves. One is a rectilinear line, the other one is a parabola, but the input is the y. So if I want to find the area between them, between the bounded by the two curves, I need to find this area, all this area that is here. And I need to do pieces like this, areas like this. The area of this have, the dimension of this area have, the width is the ddx, and the length of this is the upper minus the lower. The upper is y plus 2, and the lower is y square. So, so this is the area, the small area of a tiny piece. So I will do the area by summing all the pieces. So the area will be this, sorry, it's not by ddx, it's by ddy. Oh, ddy. So the area, the small area of a piece will be y plus 2 minus y squared, that is the length, this vertical length, multiplied by ddy, by the width, by the width of the elements. So, and I will sum. So the area will be, so I will find the intersection point. The intersection point are when y squared equal y plus 2, when x equal x. When x equal x, wow, y squared equal y plus 2, this will take me to the point y equal 2 and y equal 1. So y equal 2 will be this point, and y equal minus 1 will be this point. So I know what I have to do. I have to do the integral from y equal minus 1 to y equal 2 of all these elements, from y equal minus 1 to y equal 2, the sum. So this is the integral. The sum is the integral, and we make the integral. We evaluate between -1 and 2, and the problem is set up. But this is not exactly what the problem wants to do. The problem, I am still creating vertical elements of area, vertical rectangle. What the problem is asking is to create horizontal elements of area. Instead of making vertical elements of area, to fill the space inside by elements like this, horizontal elements like this. And now you put another one, and you put another one, and you put it here inside to fill the space. So the sum of all these elements of area with the height of the element of area is now, well, in this case, if I choose the direction x, the height will be ddx. And let's go to do it as they want you to do it. Let's go to the next page. Now the problem wants to represent the function x of y equal y squared and x of y equal y plus 2, and to see the area between the two curves. Okay, what is x of y equal y squared? Well, you plug in a y, and you see now there is the y-axis, vertical axis, and the x-axis, the horizontal axis. I'm not doing what I did in the previous, in the same problem when I draw here the x and the y to avoid this. Well, but it's nice to understand this. What it say x of y equal y squared? Take y, let's say 1. So the x will be 1 squared. So if I stop at the point 1 here, the x will be 1 squared, will be 1. From here to here will be 1. Take y equal 2. So the x will be 2 squared. So if you stop at 2, this distance will be 4. Okay. Takes y equals 0, so the x will be 0 squared. So it will be this point. Take y equal -1. So the x of -1 will be -1 squared, which is 1. So if I stop at y equal -1, the x will be 1. And if I join up same thing for y equal -2, the x will be 4. And if I join all the points, I will find a parabola. In this way, I draw the graph x of y equal y squared. What is the graph of x of y equal minus y squared? Will be this parabola. Okay, this parabola. Do you see? I don't want to draw it. Well, I will draw it, goes to 0 and goes like this. But I don't want to draw this parabola, not to get dirty my draw. Okay, so what is the graph of x of y equal y plus 2? Take a y and you will have an x. Take the y equals 0, so the x will be 0 plus 2. So if I stop at y equals 0, the x will be 2. If I stop at y equal 1, the x will be 1 plus 2, 3. So I stop at y equal 1, and all this distance will be 3. So now the idea, so if I stop at y equal 2, the x will be 4. So if I stop at x equal 2, the x will be 4.
So it's the same x for the parabola that for the rectilinear line. So y equal to is the intersection. Okay. So the idea of this picture is to fill the region that is in this between the two curves is this region, but I'm going to erase this region. You see the region between the two curves. Let me erase it. Okay. The idea is to fill the region by horizontal rectangles. Who are these horizontal rectangles? Elements of area like this one. And these elements have a length, and the length of this element is x, the further curve. Let's go to call it x2, the rectilinear line, the further one, x2 of y minus x1 of y. This is the length of this element of area. And now the width is d dy. So the sum of all the elements is the integral. The sum of all the elements is the integral of this expression. As I said, the important thing here is to make the setup. If you try to find the point of intersection, it's down here. So let's go to, it's down here, the point of intersection are y equal minus 1 and y equal 2. Very easy, yes. Impose the condition that x1 of y equal x2 of y squared equal y plus 2, solve it and you will find the y at which the two curves intersect. So now let's go to do the setup of the problem.
Now it comes the setup. I'm going to do small areas to fill the region bounded by the two curves, but the small area will be horizontal rectangles like this. So these horizontal rectangles, they have the size, this is x1 and this is x2. So the size, this is x1, and everything until here, from here to here, is x2. So the size is x2 minus x1. And the height of the rectangle is d dy. And the area of the rectangle is x2 of y minus x1 of y by d dy. And the total area is the integral or the sum of all the pieces. Is the integral of x2 of y minus x1 of y by d dy. And this I have to make the sum from y equal 1. Let's go to put y equal 1 to y equal 2. So I will walk in this direction, d dy. So let's go to do it. So x2 is y plus 2. The more to the right, the graph more to the right, y plus 2 minus x1 y squared d dy, and the integral is from y equal minus 1, y equal minus 2, y equal 2. The result, you can check it, should be 9/2. Go faster. Find the area of the region bounded by the curve y equal cosine of x. Y equal cosine of x is this graph. And y equal 2 minus cosine of x is this graph. And they say find the area bounded by the region of the two curves between 0 and 2 pi.
So they refer to this area. This area, they refer to the sum of all the pieces like this one. Why should I not do horizontal rectangles? It will not work. Vertical rectangles will work. So we'll do the upper curve minus the lower curve. This is this size. This is the upper. The upper is 2 cosine of x, 2 minus cosine of x, minus the lower, minus cosine of x. 2 cosine of x minus is the size, is this size, multiplied by d dx. I go in the direction of the x, so this is d dx. And the area is 2 minus 2 cosine of x by d dx. And this is the area of small pieces. And what I have to do is to sum all the pieces, to sum this piece with this piece with this piece, and to sum when x goes from 0 to 2 pi. So the setup of the problem is make the integral from 0 to 2 pi of the upper function, or the top function minus the bottom function, the top minus the bottom, 2 minus cosine of x minus cosine of x. And the integral is 2 minus 2 times cosine of x, and the integral between 0 and 2 pi is 2x minus 2, the integral of cosine of x is sine of x, so it will be minus 2 times sine of x. Evaluate between 0 and 2 pi. From 0, this is 0, sine of 0 is 0, so 0 is a good point for evaluation, and 2 pi will be 2 times 2 pi, 2 times 2 pi minus 2 times sine of 2 pi, and sine of 2 pi is 0, so it will be 4 pi. Okay, and this is the area. Okay, let's go to another problem. Find, as I said, the thing here is the setup. It say find the area bounded by the curve y equal x raised to the power e to the minus x squared. This is the curve e to the x by e to the minus x squared. Nice curve. Has a maximum, has a minimum. It's a nice curve. X to multiplied by e to between y equals 0. Y equals 0 is this line, is the x-axis. Y equals 0. 0 between 0 and 1. So it's asking me by this area. It's asking me by this area. What is this area? Well, the upper curve is this one, and the lower curve is the curve y equals 0. So the upper minus the lower. So it will be the integral, the setup will be the integral of the upper minus the lower d dx. So this will tell me what is the sum of all the pieces like this one. I'm summing pieces like this one. For example, I'm starting with a small pieces here, a small piece. Later on comes a bigger piece. Later on comes a bigger piece. When it's at the maximum, it comes a bigger piece. Now a small piece. And now a small piece, and between 0 and 1, these are the pieces. But these pieces, the integral makes infinity pieces like this, because we make the limit when n tends to infinity, and we make the sum of all the areas, the sum of all the pieces in the limit when n tends to infinity. And this is the integral. So we make the integral from x equals 0 to x equals 1 of x multiplied by e to the minus x squared. How we can do this integral? Well, we make substitution, u equal x squared. The derivative of u respect to the x is 2x, so d du is 2x d dx. And x d dx is here, is sitting down here. So here, this is x d dx, which is d du divided by 2. So d du divided by 2 is x by d dx, and we do the integral, and you know how to do the integral, and I think this is the result, unless I did a mistake. So this is the area between 0 and 1. This is this area, the regions. This is this area that is here. I hope I didn't make any mistake. Go to the next one. Find the area bounded by the curve. 3x cubed minus x is this area, this graph, the graph of this function. X cubed always does like this. Minus 3x. 3x, sorry, this is 3x cubed minus x. This is the graph of 3x cubed minus x, and the graph y equals 0. So I have to be careful because this is the graph y equals 0, and the upper function, this is y equals 0, on the x-axis, and the upper function is this one from minus 1 to 0, but the upper function is the y equals 0 from 0 to 1, and the lower function is this one, the lower one on the interval 0 to 1. So I need to do the area bounded between the two functions step by step. First of all, I need to do the integral from x equals minus 1 to x equals 0 of the function minus 0. And later on, I have to do the integral from x equals 0 to x equals 3. This point is the point 3. Yes? No, sorry, this is the point 1. This is the point 1. This is the point 1. I can see that it's a 1 here. So is the area of the upper curve, the y equals 0 minus the lower curve. So doing this integral is easy and evaluating. I think that the total answer is 6/4. Okay, 3/2. Okay, let's go to the next problem. The next problem says find the area bounded by the two regions y equal x minus 1 cubed and the rectilinear line y equal x minus 1. So I have drawn these two lines, and the area that they refer is this area. The limit of integration are from 0 to 1 and from 1 to 2, and the setup, of course, that I'm assuming that you know how to obtain this point x equal the point of intersection x equal 2, and this point of intersection x equals 0. Just put this equal this and you will find the x. Okay, but let's go to make it shorter. And the setup will be, imagine these elements of area. This element of area have a height, and the height is the upper curve. The upper curve on the interval 0 to 1 is x minus 1 cubed minus the lower curve, x minus 1. And the width of the elements is d dx. So the small area that is here is the height by the width, x minus 1 cubed minus x minus 1 multiplied by d dx. So the total area A, the total area from x equals 0 to x equals 1 of the top function minus the bottom function, x minus 1 cubed minus x minus 1 d dx. This is this area. This area. Now we need to sum the other area. What is the other area? The other area is the integral from x equal 1 from here to x equal 2,
x equal 2, or the upper from x equal 1 to x equal 2, this is the one, is x minus 1 minus the lower. The lower is x minus 1 cubed ddx. So making this integral, you will have the answer. Not difficult to do this integral. And let me see if I can find the result. Well, it doesn't matter. This is the setup is what is important. Okay, this is a problem 9 say like this. It say you have two functions, x of y equal 4 minus y squared, that is this function, and x equal y minus 2, where is this function, this is the y-axis, this is the x-axis. I'm going to assume that you know how to represent this function 4 minus y squared, and the idea is you stop at y equals 0. Y equals 0 is here. Y equal 1 is the horizontal line y equal 1. You stop at y equals 0. When y equals 0, the x is 4. 4 minus 0. So in y equals 0, the point of this parabola is here at x equals 4. At y equals 0, the x of the rectilinear is 0 minus 2, which is minus 2, x equal minus 2. So at y equals 0, the rectilinear line crosses the axis at x equal minus 2. And this point is when y equal 2. When y equal 2, the x is 0. And when y equal 2, the x of the rectilinear line is 0. So both are intersecting. And you know how to find this point, but imposing the condition that x of y equal x of y, x1 of y equal x2 of y. Maybe it will be more clear problem if you write x1 of y and x2 of y. Now, this problem why is interesting? Because you can do it in two ways, but there is one way that is easier to do it. If you want to fill the region between the two curves, but by rectangles, you can fill it in with vertical rectangles like this, or maybe vertical rectangle like this, vertical rectangles. You can fill it with many vertical rectangles, infinity many vertical rectangles, and you fill the area. Okay, this is one possibility. If you do it, you have to be careful, because when you arrive to x equals 0, the region is the region in the first curve. There is no area between two curves. It's the area that is here of the same curve, the parabola, and is the same area below the curve. So you have to be careful if you do vertical rectangles. If you do it, you need to make the calculation like this. From minus 5, x vary from x minus 5 to 0. Of what? Now is the upper minus the lower. The upper is x plus 2. The lower is, and the lower is have to be careful. The lower will be like this. X equal 4 minus y squared. So y squared equal 4 minus x. So y is equal plus
square root of 4 minus x, or minus square root of 4 minus x. So the lower curve is this part of the parabola, is y equal minus square root of 4 minus x. But the minus minus, the upper minus the lower will produce a positive sign. So you have to be careful here. You do first the integral from x equal minus 5 to x equals 0, doing the vertical elements of rectangles, of area of rectangles. And later on you keep going vertical areas, but you are doing only this rectangle and multiply by 2, because the symmetry will say that 2 times the area will find the total area of the whole region. Okay, but now let's go to compare with the vertical, with the horizontal, when we fill the region between the two curves with horizontal elements of area, like this one. x2 minus x1 by d dy. This is the element. It's the square root of 4 minus x, because you will do 2 times this area. 2 times the area that is in this area plus this area. There is a symmetry, so it's the same area. So it's 2 times the area is a square root of 4 minus x. The square root of 4 minus x 2 times, from 0 to 4, and you will find this result. Okay, the interesting point here is that you can fill the region between the two curves by horizontal elements of rectangles. So if you fill it with horizontal element of rectangles, you can do the area in one shot, one only integral. So you do this area plus this area plus this area, of course infinity elements of area. So you have to do, so the calculation is the one that is more to the right is the parabola, minus the one that is to the left is the rectilinear line. And as you see, the parabola is always, in this region, is always to the right. So let's go to see the calculation. So the calculation will be like this. Is the area will be, so from y equal minus 3. Y equal minus 3 is the rectilinear, the horizontal line here. Y equal minus 3. Okay, to y equal 2. So d dy is going up, d dy is going up, d dy of the function that is to the right. The function that is to the right is the parabola x2 of y minus x2 of y, let me write here, x2 of y minus x1 of y. So the x2 of y is the parabola. So it's 4 minus y squared. And the x1 is the rectilinear line, so it's y minus 2. So the integral d dy is done. It's in one shot. You fill the space with horizontal elements, horizontal rectangles, and you fill in one shot. So you make only one integral from y equal minus 3 to y equal 2. Okay, let's go to the last problem, I think, and I hope. Okay, now let's go to solve the last problem, finally the last one. It say like this: set up and evaluate the definite integral that gives the area of the region bounded by two graphs. The graph is f of x, the first one is x cubed. So it's this one, the graph x cubed have a slope 0 at x equals 0 and goes like this. And say the other graph is the tangent line at 1.1. So we need to find the equation of this tangent line. And once that we found the equation, we need to find this intersecting point, and we need to fill the area with rectangles. We will choose vertical rectangles. Yes, why not? We will choose vertical rectangles like this one. Well, we will realize that the upper function is the x cubed. On this graph, the upper function is the x cubed, always. We can find this point, the point of intersection of the rectilinear line, but to find the intersection of the rectilinear line with the graph y equal x cubed, we need to find first the rectilinear line that is tangent to the point 1, 1. So, what is the slope of the function x cubed, 3x squared? What is the slope at the point x equal 1? The slope at the point x equal 1 is 3. Okay. What is the rectilinear line that is tangent to the point x equal 1 of the graph x cubed? The rectilinear line is y minus y0 equal m, the slope, multiplied by x minus x0. So the equation of the rectilinear line is y minus 1 equals 3 times x minus 1. So y, it will be 1 plus 3x minus 3, or in other words, it will be y of x will be 3x minus 2. So y of x is the bottom graph, the bottom curves. So I will do the upper curve minus the bottom curves between x equal minus 2 to x equal 1. X equal 1 is here, x equal 1 is here. And x equal minus 2 is the point of intersection of the graph x cubed with the graph 3x minus 2. Let's go to see. If I plug in x equal minus 2 to the cube will be minus 8 equal 3 by minus 2 minus 6. Minus 2 is minus 8, but you need to find this point of intersection. Okay, I have checked that this is the point. You need to find it. You know how to do it, I think. So this is the setup of the problem, this one, and the problem is done, and this is the area between the two curves. This is this area. Okay, and have a good night. I wish you all the best in the test.